What is up, you filthy teenagers? Welcome to another SIP Mr. Zoyas math lesson. Today we are going to talk about imaginary numbers. We're going to talk about how to deal with them, how to cope with them. Life can be very difficult sometimes, and sometimes we need imaginary numbers to get us on through those tough times when we don't have any friends. And I think that's kind of the moral of the story. Sometimes you don't have real numbers and you got to make imaginary numbers till you get out of middle school and you outgrow that awkward phase and you cut your long emo hair. I'm just kidding. Okay, let's go ahead and get down to the math. So imaginary numbers are not fake numbers, but rather the counterpart of real numbers. Okay, and this common misconception that imaginary numbers are like fake numbers, or right? At least we hear that and we think, oh dang, math is hard enough, it's already voodoo, it's already black magic, now we're gonna start imagining stuff. No, that's not the case, right? They are the counterpart to real numbers, and real numbers are just things like pi, -1, 2, 0. Real numbers are any number we can think of that can fit on the number line. Okay? So, on the real number line, right, and this is the number line we learned back in 6th grade, the imaginary number line extends perpendicular, like the y-axis. Okay, so we're going to have our imaginary number line going perpendicular to our real number line. Alright, this is our real number line right there. Oh, that's really too tiny to see. But you get the idea, and then this is the imaginary one, right? And think about it like they're two sides of the same coin, right? Imaginary is just the opposite of real, and that's why we put them perpendicular to one another, right? It's like that second dimension, and that's even what it says right here. Thus, imaginary numbers can be thought of as, the spelling typo, a second dimension of numbers. The imaginary realm of numbers is entered when taking the square root of a negative number. Okay, so we have the second dimension of numbers, and how we get there is whenever we take the square root of a negative. Right, the square root of a negative, and we're going to look at the most basic form of it and come up with a little bit of math that we can then use. Thus, we define an imaginary term to be the square root of -1, or I equals the square root of -1. Okay? Right, and notice that's just the square root, and I'm putting this 2 up here just to kind of help you guys understand that we're taking the square root, and we're ultimately, when we simplify these, we're going to be looking for 2 copies of multiplication to pull out of here. But understand that if you see that, and there's no 2 there, it's just the square root, right? We can write that without the 2, and it still means the square root. And again, that's because it's the most common kind of root, and so when we write it without a number there, it's assumed that we're taking the square root. Okay? And so this is going to be, I want to call it our bread and butter, but that's not the right term for it. This is going to be the tool that we use, right? This is what's going to open up a whole realm of problems for us to do, right? That little thing right there, and you're going to see as we start doing some of these examples, that's going to be what makes these impossible problems possible. Okay? So let's go ahead and start. So we're looking to simplify this term. Now, first things first, we see a negative under there. Let's go ahead and distill that. Let's go ahead and separate it from the 49, or from the number that it's multiplying to. So we see a negative in there, and we know that's really just the same as -1 times that number. And really important tip, I see so many people do this, they don't extend the tail of their radical, or their root, remember they're the same thing, over the entire thing. Think of it like this, if it's inside the root, the tail needs to cover it. So we can just think of that as -1 times 49, right? And so then, what we can do is we can break apart this root. And we can break it apart at the multiplication. The reason being because a root is just another type of multiplication. It's a type of repeated multiplication, kind of a half multiplication, if you want to think of it like that. Alright, so we can break the root apart at multiplication, that's okay. Can't do it at a plus sign. Just side note, because this is a very common misconception. People think, you know, square root of 9 plus 9, oh, I got that. It's this. But that is not the case. Can't break it apart at the addition sign, can only break it apart at multiplication or division. Okay, so this is a big no-no. And if you don't believe me, go ahead and try it out on your calculator. See how these two things do not equal one another. Okay, so now we broke this apart, and what do we notice that we can replace with something that we just learned? Hint, hint, wink, wink. Right? The square root of -1 can be replaced with I. Congratulations, ladies and gentlemen. We have just entered the Twilight Zone. I'm just kidding. But we entered the imaginary realm. We're now dealing with imaginary numbers, and it came about because we had the root of that negative. Right? So this is equal to imaginary square root of 49. Okay? Now, how I'm going to recommend all you guys simplify radicals is by doing the prime factorization of the number. And what that means is you write the number up there, and you look for numbers that are going to multiply to that. So let's go ahead and brainstorm what numbers can multiply to that. Well, oh, I got it. 7 and 7 can multiply to that. Can 7 and 7 be broken down any further? Besides just breaking it down to 7 and 1. Okay? Because that's redundant. Right? We already were there. So we don't want to do that. And that's actually the reason why we call 7 prime, because we can only divide it by 7 and 1. So we can't divide it any further, so that's our prime factorization of it. And we're going to replace that with 49, because 7 times 7 is equal to 49. Again, don't believe me, try it out on your calculator. Okay? And now, so to deal with these square roots, you know, it's ultimately looking for half multiplication, which really just means that we're looking for pairs of things multiplied together under the square root. And when we find those pairs, we can take them out and group them together as one, right? I have two 7s right there. They group together to make 1 7. Alright, so equals I, and those 7s come out to make 1 7. So that simplifies to imaginary 7, right? It's like a normal 7, but it's imaginary. Okay? And notice, it was all because of that negative, right? So let's go ahead and do this as well. Right, moving on to example number 2. So again, we're going to start off, we see that negative in there. Let's go ahead and separate that from the rest of the number. So we can write -1 times 136. Alright. And now we can break the square root on that multiplication. Right, that's okay because the square root is just a kind of multiplication, and so it's okay to break it across the square root, or across the multiplication. And so we end up at the same situation where we have the square root of -1 times the square root of 136. Right, and what do we know the square root of -1 to be? This is going to be memorized like the back of your hand. We're going to do it so much. And it's going to be so useful, incredibly useful. Okay, so now this is, and side note, this is the part that's pretty difficult for most of you guys. We just now need to simplify that square root, right? We did the imaginary part. The imaginary work's over. If anything, that's probably the easiest part. Now we need to look at simplifying this, which I know you guys struggle with. So I'm going to use my handy dandy calculator, aka phone with a calculator on it, to go ahead and to go ahead and calculate what this could be. Alright, I see you guys, I know you're probably looking at my notifications. There's nothing interesting to see there. I'm old. That's what happens when you get old. Your phone gets boring. Okay. So, 136, we're looking to break that into its factors. And so we're just going to start this game by writing 136 up here, and then looking for numbers that multiply to it. Pro tip, the easiest way to do this just start by dividing by numbers like 2 and see what it gets you. Cool. Right? So 2 times 68. Right? Divided it by 2, which means 2 times 68 is going to multiply to 136. So now I get 68. Let's go ahead and divide that by 2. Cool. I get 34 and 2. Let's go ahead and divide that again by 2. We get 2, and we get 17, okay? Now we get to 17, and we think, well, geez, what's going to divide this? So let's go ahead and try some things out. So does 2 work? No, it does not. Remember, we want to divide it evenly. 3 doesn't work. 5 doesn't work. Does 7 work? No. And you can keep on trying this process, but what you're ultimately going to find out is that 17 is a prime number. That there is no number that can evenly divide it. Okay? So 17 is prime, and we can stop there. So what does this mean that we have? We have a 2, a 2, a 17, and a 2. Right? We take what is at the bottom of our prime factorization, because all these things multiplied are going to equal the number at the top. Alright? So we can write equals I times the square root of 2 times 2 times 7 times 2. Right there. Okay, cool. Now we are ready to play our game of group up and go outside the radical, right? Because remember, the square root is looking for half multiplication, so that means we're looking for pairs of multiplication to pull out, right? And when we pull them out, they become just 1. So let's go ahead. We are going to look for pairs, so I see a pair of 2's, right? And the pair of 2's are right there. They can come out. We'll look for another pair. Well, that 7 is alone. It doesn't have a pair. And that 2 is also alone. It does not have a pair. Okay? So ultimately, what that means is we are going to pull out a 2. And that's just going to become a single 2. That pair of 2's gets pulled out to become a single 2. And then anything we have left behind just stays under the square root. So what do we have left behind? We have a 7 because he has no friends and he was super awkward in middle school. And we have a 2 left behind because even once he got to high school, he still didn't acquire social skills, and that's why he ultimately became a math teacher. And I mean, okay, so 7 and 2 get left under there, which is just 7 times 2, and I promise I'm not 7 and 2. I don't even like those numbers, and 7 times 2 can be turned into 14. So our final simplified answer is I imaginary 2 square root of 14. Okay, just disregard whatever happened there. I don't know. I get into these videos and sometimes just the truth comes out sometimes when you least expect it. Okay, now moving on to another example. So, right, there's many things we can do with this square root of a negative, right? There are many situations that we just couldn't handle because it was the square root of a negative, but not anymore. So let's go ahead and look at another example where we can apply this, layer it into our bank of previous skills, and just do some cool math with it. So, okay. So let's go ahead and solve this problem. So it doesn't give us directions, but we've seen this so much, we know what to do. We are solving for x because we are given a y. So let's go ahead and plug in y. That's our first step. Alright. Now, cool. I am solving for x, so what is the next step I'm going to do? I'm going to subtract 2 to get rid of that. And that's going to bring me to 98 on the left. And then just negative 2 times x minus 4 squared. Alright. And now I'm going to want to get rid of that negative 2 that's multiplying. It's multiplying, so I'm going to divide. So I'm going to divide by negative 2 on both sides. Alright. And 98 divided by negative 2, that is just going to be 49. So, and that's going to be a negative 49 equals, and then those 2's are going to cancel out, so we'll have x minus 4 squared. Oh no. Right? You guys see it coming. Right? What's next? The square root. Right? We're going to take the square root to get rid of that square. And we're going to do that on both sides, and lo and behold, we just took the square root of a negative. So what does that give us the opportunity to do? What realm of numbers does that put us into? You guessed it, the imaginary number realm. And side note, don't forget to add that plus and minus there. Remember, when we're taking the square root, we could have had a positive solution or a negative solution that could have satisfied that. So we're going to write plus or minus. Okay? So we will have plus or minus the square root. And again, I'm going to be very well trained in my method here. Alright, I'm going to go through all the steps. I know you may be able to skip some of these, and if you can, more power to you. Oops, okay, we'll just run with that. If you can just skip that step where you're separating it and doing all this, you know, if you can just go from something, here, I'll show you in a second. Alright, and right here we are separating the root. If you can just go ahead and skip some of these steps, you know, skip some of these simplification steps of the square root, more power to you. But if it's difficult, if it's just too much on your brain, go ahead, let the paper do the work. Right? Write it out. Show your steps. Take that load off your brain. You need your brain to navigate through this. Don't bog it down with all these simplification steps if you can't do it. Right? If you can just go from there to there because you just see it, do it. And good for you. But if you're not there yet, that's okay. We're gonna get there, and just be patient with yourself. Okay, so if you can't go from there to there, just go ahead, separate that negative 1 from the 49, separate or break apart the square root, and then take the square root of each. Right? And we just learned the square root of negative 1 is I, and likewise, like we saw earlier, the square root of 49 is 7, because 7 times 7 equals 49. Okay? Now, the last and final step to solving for x, we're going to add 4 to both sides. Right? And we're going to go up here with it. Take this math problem up here, because we're running out of space. And we will have plus and minus 4i 7, or imaginary 7. And that's equal to x. Okay, remember, we have two solutions here. Right? We have the plus and we have the minus. A plus solution and a minus solution. Okay? So now, these are our two solutions, right? And we could also write them like this. X equals 4 plus imaginary 7. And we can also write 4 minus imaginary 7. Okay? And so the other thing, kind of like we noted up here, is that these imaginary numbers are now going to dramatically change our number line. Right? Our number line normally looked just like this. Right? Just a simple one-dimensional number line. But then, Exhibit came along and he said, yo, I heard you like numbers, so we're going to give you an extra dimension of numbers. Right? And then we got that extra dimension of numbers, and so now we have what's called a plane, a two-dimensional plane. Right? It went from one-dimensional to two-dimensional. And so now we can actually go ahead and plot these numbers on our plane, right? It's 2 dimensions now, it's a plane, just like we would a coordinate point. Identifying the real parts and plotting that against the real axis, and identifying the imaginary parts and plotting that against the imaginary axis. And let's go ahead and see how this looks. So we have a real part of 4, so we're going to go over to 4. And then we have an imaginary part of 7, so we're going to go up to 7. That actually turns out to be just barely off our axis. But you can imagine, right, that would be like 7i. And so that would be our point, 4 plus imaginary 7. Crazy, huh? Right, like this gives me goosebumps every time I talk about it, because it is just kind of such a mind blow and such a connection of things we already know, things we thought we knew, but turns out we actually didn't, and just combines them together to give us some really innovational math. So now let's go ahead and also plot that second one. So we have 4 minus imaginary 7. Okay, so we're going to go over 4, right, on the real part, because that's our real number. And then a minus imaginary 7. So we're going to go down 7 on the imaginary part. And that's going to put us somewhere right about there. Okay, and that is our 4 minus imaginary 7. Okay, and that's that number. Just like that. And I'll even put these in parentheses just so they look a little more like a, a solid quantity. Right? And let's go ahead and take a look back at this and think about this. We have 2 plots because we have 2 solutions. Why do we have 2 solutions? Because we took the square root. Okay, so that makes sense. Everything looks good in the hood. Next problem. Right? This is a toughie. This is a good one. This is a good challenge problem. Some would say this is even a good quiz problem. Hint, hint, wink, wink. So let's go ahead and do this. What are the solutions to x when y equals 2 for the what am I talking about? Y minus 1 equals 4 times the quantity x squared plus 1/2 to the power of 2. Right? What is x when y is equal to 2 for that equation? Okay? And so notice what's unique about this. Some of you guys, this may actually scare you. If it does, don't let it scare you. All right, we want to stick to our methods and go through this the way we would anything else. All right, but what do we notice that's different? There's an x squared inside of a squared term. Okay, so this is actually not a square term anymore because this is ultimately going to give us an x to the power of 4. If you're not sure about why that is, that's okay. That'll come in later lessons. But understand that now we're talking about not a square function. We're actually talking about a quadruple function. I actually don't know the name for it. We would just call it x to the power of 4, or a power of 4 function. But right, so we may get some weird results, but again, let's stick to what we know. Let's stick to our methods and just go on through and see where the math gets us. All right, so we have y equals 2. So we are going to take this equation and substitute y equals 2 into it. 4 parentheses x squared plus 1/2 close parentheses squared. Okay. So first things first, right? 2 minus 1. Let's go ahead and simplify that. That's just going to be 1. So 1 equals 4 times x squared plus 1/2 squared. Okay. Now, what's the next step? Remember, we're trying to solve for x. You may say, oh, let me go ahead and take the square root. But wait, there's a 4 that's multiplying it. We want to get rid of that first. So we want to divide by 4 on both sides. All right, and that's going to give us 1/4 over here. And you can write that as a decimal if you want, but you're going to see in a second that it's actually a little more advantageous, a little easier to write 1/4. Okay, so we're going to have x squared plus 1/2 squared. Alright, now what's up next? We see the square term is next, and we're just going to follow what we know, right? When we see a square, we get rid of it with the square root. Whenever we take the square root, we write plus or minus. Okay, so let's go ahead and follow what we know and just stick to the math. Okay, so that square root is going to get rid of the square. So that's going to give us x squared plus 1/2. Right, now plus or minus the square root of 1/4. So again, understand that division is just another kind of multiplication. Right, and I know that may be mind-blowing. You always think of them as opposites, but think about it like 1/4, 1 divided by 4 is the same as 1 times 1/4. Right? And if that's hard to sink in, that's okay, but just understand that when this is multiplication, we can break up that square root the same way we did before, just like that. And that's a lot more manageable, right? So that becomes plus or minus square root of 1 is just 1, square root of 4 is 2, equals x squared plus 1/2. Awesome. Okay, let's just kind of keep on going on doing the math, right? I know we see that square term there, but don't worry too much about it. We're going to get there. So let's go ahead and take the square root of -1. What am I talking about? We're going to subtract 1/2 from both sides because we had plus 1/2 over there. Alright, so let's bring this back up. So we're going to have -1/2 plus or minus 1/2 equals x squared. Okay? So now there's a few different things you can do here, but just for the sake of keeping this consolidated, I'm just going to keep it in this notation and just solve this as though it's one equation. Right? Remember, we have two options in here, but we can continue to solve it like it's one equation. Now, for people, if that may bother you and you just think there's too much going on, you need to simplify it, sure. You can go ahead and you can write this as -1/2 plus 1/2. So -1/2 plus 1/2, what's that? That's 0. 0 equals x squared. And also -1/2 minus 1/2, that's going to be -1 equals x squared. You can think of it as these two equations and then solve these independently if you want to. But I'm going to save that till the end and just go ahead and take the square root of both sides. Okay, and I know it's going to look big, it's going to look messy, but again, that's okay, right? We're going to stick to our math, we're going to stick to our methods, and we're going to just see where this takes us, right? Have faith in your methods. That is probably one of the most important lessons you can ever take away from math, and one of the biggest skills that any mathematician has is just pure faith in their logic and reasoning. Okay? So we take the square root of it, writing that plus or minus out there again, and then we have x equals plus or minus the square root of -1/2 plus or minus 1/2. Alright, so let's go ahead and let's think about this real quick. So this is actually a little bit of a permutation problem, right? How many different options are there? And think about it like this. We have a positive and negative option right there, and another positive and negative option right there. And each of these has two options each. Right, so that means when we choose the plus, we'll have two options. When we choose the minus, we'll still have two options. Okay, so these two options and these two options give us 4 total options, aka probably 4 solutions. We're going to go ahead and see if that's the case, but we know there should be at most 4 solutions. Sometimes there's a little bit less, depends on the case. Okay, so we're going to go ahead and simplify this. So -1/2 plus 1/2, well, that just turns into 0, right? So that becomes the square root. And what we're going to do is we're going to write all of these out. We're going to list them. Okay, so like we said, -1/2 plus 1/2 is going to become 0, and the square root of 0 is still 0. So we're going to have plus or minus 0 for that first part. Okay, and realize, right, we can say plus 0, and then for our second solution we can say minus 0, right? We can break that apart into our two solutions, but realize that's 0. There's no positive and negative to 0, right? And that's kind of what's crazy about 0, and that's why it took colonies and civilizations so long to think of that, right? A number that doesn't have an opposite. Whoa, that's crazy. Even infinity has an opposite. Alright, so we do that. Now cool, let's go ahead and check it out when we have the minus 1/2. So -1/2 minus 1/2. Right, that's going to be -1. The square root of -1, what do we know that to be? That is I. Right, so we'll have plus or minus I. So we can have a positive I or we can have a negative I. Alright, and I feel like there's a lot of math that went on there, so let me go ahead and show the work for that. Right, so checking out the case plus negative 1/2 minus 1/2 is equal to the square root of negative 1. Negative 1/2 minus negative 1/2 is negative 1, which is equal to I. Alright, that's how we got that first one. Then the other one would be minus the square root of negative 1/2. And that's going to turn out to be the square root of negative 1. But remember, we had that negative in front, negative the square root of negative 1, which is going to turn out to be negative I. That's where we get that negative I from. Okay? Right, so we want to say 4 solutions, but remember, that's the same number. 0, negative 0 are the same number. So really there's only 3 solutions for this, and that's one of those special cases I was talking about in which we wouldn't have 4 possible solutions. Okay?